The proliferation of small, low-cost, unmanned aerial systems has introduced a persistent surveillance and strike threat, significantly complicating operational planning. Military forces must now operate under the assumption of continuous aerial observation, where even low-end drones can provide real-time targeting data. When combined with advances in satellite reconnaissance, the modern battlespace has become increasingly transparent and contested, reducing the effectiveness of traditional concealment and maneuver. In response to this evolving threat environment, Lockheed Martin has unveiled the Grizzly containerized launcher, a system specifically designed to preserve survivability through concealment rather than conventional stealth. Encased within a standard 10-foot cargo container, Grizzly leverages a hide-in-plain-sight concept, allowing it to blend seamlessly among commercial shipping containers and thereby generate significant targeting ambiguity for adversaries. Its containerized architecture ensures compatibility with existing logistics infrastructure, enabling rapid and discrete transportation via trucks, aircraft, and maritime platforms without the need for specialized handling equipment. In this video, Defense Updates analyzes how Lockheed Martin's Grizzly launcher could redefine battlefield surprise. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. The Grizzly launcher is engineered around a standardized 10-foot ISO container, Tricon form factor, transforming a conventional logistics unit into a self-contained precision strike platform. Within this enclosure, Lockheed Martin integrates a reinforced internal frame that supports the launcher modules, missile canisters, power supply, and control electronics while maintaining structural integrity during transport and firing. The internal layout is optimized for space efficiency and shock isolation, ensuring that sensitive components remain protected under dynamic loading conditions. A modified launcher assembly, derived from the M299 architecture, is mounted inside the container in a vertical or near-vertical orientation, enabling a compact footprint while preserving effective launch geometry. The M299 launcher is a digitally controlled, modular air-to-ground missile launcher. Unlike earlier analog launchers, the M299 integrates digital avionics, standardized weapon interfaces, and modular electronics, enabling it to function as a smart launcher capable of managing multiple missile types simultaneously. The launcher is engineered as a compact yet structurally robust carriage system capable of accommodating up to 4 Hellfire-class missiles in a 2x2 stacked arrangement. Its architecture is centered around a load-bearing central spine, which transfers aerodynamic and inertial loads from the missiles to the aircraft pylon, ensuring structural integrity during high-maneuver flight regimes. Extending from this spine are 4 independent launch rails, each equipped with its own electrical and mechanical interface, allowing complete autonomy in missile selection and firing sequence. The launcher integrates umbilical connectors and wiring harnesses within a protected housing, enabling secure transmission of power, targeting data, and pre-launch initialization signals to each missile. Up to 2 M299 can be accommodated in one container. The container is equipped with a hinged roof that opens to enable launch operations. Lockheed Martin states that the containerized launcher can be configured as a self-powered system or integrated with an external tertiary power source. The container also incorporates environmental control systems, including thermal management and sealing, to protect electronics and munitions from heat, humidity, dust, and salt exposure. Externally, the system retains the appearance and handling characteristics of a standard cargo container. This design enables rapid deployment without specialized handling equipment while providing a high degree of concealment by blending into dense containerized logistics environments. A defining feature of the Grizzly launcher is its command and control, C2, and sensor agnosticism, which allows it to operate as a flexible, networked fires node rather than a platform tied to a specific sensor suite. The system is designed to interface with a wide range of external targeting sources, including radar systems, electro-optical/infrared (EOIR) sensors, and unmanned aerial vehicle feeds, enabling it to receive and process targeting data from across the battlespace. Grizzly can be deployed alone or in groups networked together. The launcher took just 6 months to build and has already successfully completed 2 live-fire tests, according to Lockheed Martin. Grizzly can be used to shoot both the Hellfire and Joint Air-to-Ground Missile, JAGM. The AGM-114 Hellfire is a precision-guided missile originally developed for anti-armor missions and subsequently adapted for a broader range of strike roles, including precision engagements against high-value and time-sensitive targets. The program originated under the designation Heliborne Laser, Fire and Forget, from which the acronym Hellfire was derived and later adopted as the missile's official name. Over time, the system has evolved into multiple variants with differing guidance mechanisms. For example, the AGM-114L Longbow Hellfire employs an active millimeter wave radar seeker, enabling true fire and forget capability. In this configuration, the launching platform can provide initial target cueing, after which the missile autonomously acquires and tracks the target using its onboard radar. With an operational range of approximately 5.5 miles, 9 kilometers, the Longbow Hellfire is well suited for integration with systems like Grizzly. Imagery released by Lockheed Martin included in its press release shows the launcher firing a laser-guided Hellfire vertically during a test. The AGM-179 JAGM program represents the evolutionary successor to both the Hellfire and the earlier AGM-169 Joint Common Missile, which was terminated due to budgetary constraints. Designed as a form-fit replacement, JAGM retains the external dimensions and production infrastructure of the Hellfire, allowing it to be manufactured on the same assembly lines while simplifying integration across existing launch platforms. Its principal advancement lies in the incorporation of a dual-mode seeker, combining semi-active laser guidance with millimeter wave radar within a single missile, capabilities that were previously distributed across separate Hellfire variants. JAGM basically adds the new seeker in the airframe of the AGM-114R Hellfire II, delivering enhanced target acquisition flexibility and improved resistance to countermeasures. The JAGM offers a strike envelope of approximately 0.3 to 4.9 plus miles, 0.5 to 8 plus kilometers, providing a versatile and modernized precision engagement capability aligned with contemporary battlefield requirements. Grizzly Containerized Launcher is not just another missile system. It addresses several structural gaps in current U.S. force posture: survivability under contested conditions, expeditionary logistics, and distributed warfare. As evident, the main advantage of the Grizzly system is its reliance on deception-based survivability, achieved by embedding the launcher within a standard ISO shipping container, rather than employing traditional, low-observable shaping or signature reduction technologies. This approach allows the system to blend seamlessly into dense commercial or military logistics environments, such as ports, depots, or forward supply hubs, where thousands of visually identical containers are present. In operational terms, Grizzly leverages ubiquity as a form of concealment, turning the logistics environment itself into a protective layer against detection and preemptive attack. Further, because of standard containerized form factor, the system can be transported via existing logistics networks, sea lift, airlift, or ground transport, without requiring specialized launch vehicles or extensive site preparation. Grizzly also enables the U.S. military to transition from platform-centric firepower to a distributed lethality model, where strike capability is dispersed across a wide and decentralized battlespace. By deploying numerous containerized launchers, each functioning as an independent precision strike node, forces can generate redundant and geographically distributed engagement capacity, significantly complicating adversary targeting and battle management. This dispersion forces opponents to allocate disproportionate ISR and strike resources to locate and neutralize a large number of low-signature targets, thereby reducing the effectiveness of preemptive or counterforce operations.